This video we're going to look at how we can use De Moivre's theorem to write powers of cos or sine in terms of either cos n theta or sine n theta, and also how we can write cos n theta as powers of cos or either sine n theta as powers of sine. Okay, there may be times as well in the exam where they'll ask you to do it just randomly, so as a mixture maybe of sines or coses, but typically they like you to do it all in terms of one trig identity, one trig equation, trig function, sorry, cos or sine. So that's how we look at what we're going to do here. So first of all, what we want to do is we're looking to find cos to the power of 6, cos to the power of 4, cos squared, and so on. So we're looking to get this thing in this form. So we're going to look at, first of all, we're going to look at cos of theta, and then plus I sine theta, and we're going to look at that to the power of 6. So by De Moivre's, that is going to be equal to cos 6 theta plus I sine of 6 theta. That's what De Moivre's theorem tells us. Therefore, you can say that the left-hand side of this thing is just the same as cos to the power of 6 theta plus I sine to the power of 6 theta. But it also, if you just expanded this thing using your Pascal's triangle, using your binomial, I'm just going to use Pascal's triangle. It's quite very quick to do. So just how we're going to get these coefficients, we could also work this out, what this looks like. So if I just do this out very, very quickly, you can see where these things are coming from, the coefficients. And the row we're looking for here. Okay, so when we expand this thing here, we know what it's going to look like. So when you expand it out, first term you're going to have is going to be just a cos to the power of 6 theta. The next term is going to be 6 times cos of theta, cos to the power of 5 theta, sorry, times I sine theta. The next term is going to be 15 cos, and the reduce the power of the cos by 1, and the power of the I sine theta now it goes up by 1, so it goes up to 2, and then we'll have 20 cos cubed theta, and then times I sine theta, and it's now cubed as well. Okay, we'll keep going, and we're also going to have then 15 cos squared theta, and then I sine theta now to the power 4, and then we're going to have 6 cos theta times I sine theta, and that's to the power 5, and then plus I sine theta to the power of 6. Okay, and then when you do that out, you're going to get, so when you do that out, folks, just take care when you're doing this. So the bit that you're going to have trouble with is when you're doing a likes of this. So you've got I sine theta to the power of 5. Now let's just look at that one. I'm not going to go through all of these, but if you had I sine theta to the power of 5, what you're going to have is I to the power of 5 times sine to the power of 5 theta. Now I to the power of 5, let's look at what that's going to look like. You've got I times I times I times I times I. I times I is just minus 1. I times I is minus 1. So it's minus 1 times I. So that whole thing just becomes positive 1 times I. So it's just I overall what that thing works out to be. So remember the identity that I times I, or I squared, is just equal to minus 1. So just take care when doing that out. So when we do those all out, what you're going to get, and we'll talk through how we get all of these here. So the first one's dead easy. There's no i's or sines involved, so it's cos to the power of 6. The next one is 6, just going to be 6 cos to the power of 5 theta times I. So I'm just going to put the wee I, squeeze the wee I in there in front, times my sine theta. And then the next one, you would have I squared, which is just going to be minus 1, so it's minus 15, and it's going to be cos to the power of 4 theta times sine squared theta. Next one, you're going to have I cubed. I cubed means I times I times I. The I times I gives you minus 1, so it's just going to be minus of 20I, and it's going to be cos cubed theta sine cubed theta. And the next one, you have I times I, which is minus 1, another I times I, which is minus 1. Minus 1 is minus 1 is plus, so it's plus 15 cos squared theta sine to the power of 4 theta. And the next one, that's the one we talked about, that was just going to be plus I, wasn't it? So 6 times I, and then we've got cos theta times sine to the power of 5 theta, and then I times I times I times I times I times I. So if we do that, you've got I to the power of 6. Another way you could look at that, by the way, is I squared cubed. And what is I squared? I squared is minus 1. Minus 1 cubed is minus 1 times minus 1 times minus 1, which is minus 1. So that means this last term, very last term you have, is just minus, and it's going to be sine to the power of 6 of theta. So what you have got so far then, you have equated this thing, and you have got that this thing in green here is equal to this. So that's what we've got. Now, remember what the question said. It said for you to find what cos of 6 theta was equal to. So it didn't mention the I sine 6 theta. So all we're going to do is we're going to equate. So we're going to equate the cos to the power of 6 theta bit, which is just the real. So you're equating the real part. Remember, this complex number is made up of a real part and an imaginary part. So the real part is the cos 6 theta. So cos of 6 theta then is equal to, and we're out of this bigger bit of the green bit here, we're just taking all the bits which are actually have no I part at all. So they're completely real. So cos to the power of 6 theta, we had minus 15 cos to the power of 4 theta sine squared theta, and then we had 15 cos squared theta, and then sine to the power of 4 theta, and then minus sine to the power of 6 theta. Now, look at the question. Always look where you're trying to get to. You're trying to get to here, and it hasn't got any signs. So we've just got to change our signs, basically, in terms of cos. Sometimes where we've got to right now is all they're asking you for an exam, but more often than not, they do want you to change it all to be in terms of the one trig function. So normally, all in terms of cos or all in terms of sine. So we're going to go ahead, write that out again, but we're just changing. And we're just changing every time you see sine squared, just change it to be cos 1 minus cos squared. So that's going to be 15 times cos squared theta. And this sine to the power 4 is the same as 1 minus cos squared. That would have been sine squared, but that has to be squared. And then the same 1 minus cos squared theta cubed for the sine to the power 6. Okay, so just a wee bit of fun just doing this out again. So we have to multiply this out. So we'll go through this as quickly as I can. When you multiply it out, what would you get? Okay, now I'm on to this one here, the 15 cos squared upon 1 minus cos squared. So if you do that out, it's been 1 minus 2 cos squared theta plus cos to the power 4 theta. And then my very last bit, I'm doing, if you did this out, and you can use your wee Pascal's triangle that you've done out here to help you here to do that. But I'll just do this out. I've already got this written out here. So that's going to be 1 minus 3 cos squared theta plus 3 times cos to the 4 theta, and then minus cos to the power of 6 theta. That's what you would get when you do that out. And then if we sort that all out, it's a bit of a mess. Sort that out, you will get cos to the power of 6 theta minus 15 cos to the power of 4 theta plus 15 cos to the power of 6 theta plus, and then that would be 15 cos squared theta minus 30 cos to the power of 4 theta, and then plus 15 cos to the power of 6 theta. And then it would be, and then I'm doing this last bracket then, so I'll just do it underneath there, minus 1 plus 3 cos squared theta minus 3 cos to the power of 4 theta, and then plus cos to the power of 6 theta. And then hopefully that is right, and yep, just therefore that means cos of 6 theta is equal to, and when you tally it up, you'll get 32 cos to the power of 6 theta minus 48 cos to the power of 4 of theta plus 18 cos squared theta and minus 1. Okay, Okay, next thing we want to do is sometimes what we did there in that last one, we wrote a cos of a multiple of theta in terms of powers of cos. You may also be asked to do the reverse of that as well. So there's a bit of stuff here for you to have a look at. I will just put this on then. You can pause the video and read through their type bit here, and then I'll show you really what I'm doing here. So just a wee bit differently maybe than the way they set it out. But have we look at that? I'm going to arrive at these results. Okay, how I like to think about this. First of all, you've got this identity here. You know that cos theta is equal to cos of theta plus I sine of theta. And then by De Moivre's, if you do the z to the minus 1 of that then, is going to be, the minus goes inside the bracket, so it's cos of minus theta plus I sine of minus theta. And that can be tidied up. Cos of minus theta is the same as just cos theta. And then the I sine of minus theta is the same as minus I sine theta. So really, that's what you've got, and that's very important then. So you know really that your z to the minus 1 is equal to this. Now, what happens here if you add both of those things? So if you add the top one and the bottom one there, so if you add this one here and this one, what you get is z plus z to the minus 1. And what happens is the I sine thetas cancel each other out, and you get 2 cos theta. Okay. Also, if you took this first one up here and you raised it to the power of n, this is what you would get. So z to the power of n would be equal to this. Likewise, z to the power of minus n would be equal to this. And then if you added those, you're going to get z to the power of n plus z to the minus n is equal to 2 cos n theta. So we've arrived at 2 identities here. So we had the 2 identities in circles there. That's what we have arrived at. Now the same thing can happen if you look at if you subtracted these things. So again, if you look at this one and this one, these two up here in yellow, and you subtract them, you're going to get z minus z to the minus 1 is equal to 2 I sine theta. So that's your first identity is. And look at the 2 in blue, down at the bottom. Z to the power of n is equal to cos n theta plus I sine n theta. And z to the power of minus n is equal to cos n theta minus I sine theta. So again, if you subtract those, that's what you get. So you've got those 4 identities in the circle. So just highlight those, and you must learn those. Or if you don't want to learn them, you need to learn how you get them. So that's the way my brain works. I prefer learning off how you get something. So I would start, if I was doing a question, I guess I would start by writing down those 2 things in yellow, and then I would work through from there to get the other 4 things. Okay, we're going to look at an example here on this. So this example says express, pardon me, it says express cos to the power of 5 theta in the form a cos 5 theta plus b cos 3 theta plus c cos theta, where a, b, c are constants. No idea. So let's get started. Let's have a clue how to do this. Let's get started, and we will soon find out. It's maybe not as difficult as it looks. So the first thing we want to do is I'm going to start, and again, I'm going to start from scratch, and I'm going to say z is equal to cos theta plus I sine theta. And that tells you, therefore, that z to the minus 1 is also equal to cos of theta minus I sine of theta. Okay? And also then, that means if I did z plus z to the minus 1, I'm going to get 2 cos theta. Also, we know that z to the power of n would be equal to cos n theta plus I sine n theta, and that means z to the power of minus n would be equal to cos n theta and then minus I sine n theta. And if you add those 2, you're going to get z to the power of n plus z to the power of minus n is equal to 2 cos n theta. So this is what is going to we're going to get started with today. So we need to find this thing. We need to find cos of 5 theta. We're not going to have that exactly, but we're going to have it pretty close, as you will see. So we're going to have 2 cos theta and we're going to raise it to the power 5. So that's where our cos to the power 5 theta is going to come from. But remember what that is. 2 cos theta is the same as z plus z to the minus 1. So it's z plus z to the minus 1 to the power 5. So again, we're using your Pascal's triangle. I love Pascal's triangle. If you don't like Pascal's triangle, just use your NCR button on your calculator. But I think it's very quick just to use Pascal's triangle for something like this. Saves me a lot of writing down, going back and forward to my calculator. I know what my coefficients are by looking at this row here. Okay, so when I expand this thing out and just leave this in terms of z's, you're going to get z to the power 5 plus 5 times z to the power 4 times z to the power of minus 1 plus 10 times z cubed times z to the minus 1 now squared plus I'm going to get 10 times z squared times z to the minus 1 to the power of 3. Going to my next line, I'm also going to get then 5 times z to the power of 1 times z to the minus 1 to the power of 4 plus z to the minus 1 to the power of 5. And if you sort that out, you're going to get z to the power of 5 plus 5z cubed plus 10, and that's going to be z to the minus 1 squared would be z to the minus 2, and then times z to the power 3 is just going to give you z, and then plus, that's going to give you 10 times z squared times z to the minus 3 would be z to the minus 1, and then plus 5 times, and then that's going to be z times z to the minus 4, which is going to be z to the minus 3, and then the last one is z to the minus 5. Now this wee bit is a wee trick part of this, and so what you want to do is group those together in a certain way. So I'm going to put the z to the power 5 along with the z to the minus 5, the z to the power 3 along with the z to the minus 3, the z to the power 1 along with the z to the power minus 1. So put them in brackets, just makes life so much easier to see. Z to the power 5 plus z to the minus 5, and then plus, and then I had 5 lots of z cubed plus z to the minus 3, and then I had 10 lots of z plus z to the minus 1. Okay, lovely. Now, look at what these will be. Going back up here to this wee identity, I'll do it in blue this time. So this wee identity up here says z to the power of n plus z to the minus n is equal to 2 cos n theta. So that means, for example, z to the power of 5 plus z to the power of minus 5 will be 2 times cos of 5 theta. This next one, we had a 5 outside it, and it was z to the power 3 times, plus, sorry, z to the power of minus 3, which is going to be 2 cos of 3 theta. And then we have 10, and this is going to be times 2 cos of just theta. Okay, so we've got that sorted out. We'll now sort out our left-hand side of that would be, I haven't done any of that just yet. I will do that now. So that all the way along, that was equal to, I'll write it in here, that was cos theta to the power, sorry, 2 cos theta to the power 5. Then the 2 to the power 5 gives you 32. Then the cos to the power 5 theta. And remember, our question didn't ask us for what 32 cos to the 5 theta. It just asked us for cos to the power 5 theta. So divide through by 32. So 2 divided by 32 would be 1 over 16 times cos of 5 theta. And then that would have been, you know what, I'm going to take an extra line there, apologies. I'm going to take an extra line, I'm going to say that is 1 over 32, and then I'll sort out this bracket. That's 2 cos of 5 theta, and then we've got the 5 times the 2 is our 10 cos of 3 theta, and then 10 times the 2 is 20 cos of theta, and then we'll multiply in. That's pretty nice looking actually as it is, but I think we will just multiply it in just for completeness. You're never too sure in an exam. Do they want this? Would they accept this? Or would they accept another line? So I would just make sure your lines are right, and then make sure you don't make a mistake going forward, and just put in the next one just in case. That's going to be 1 over 16 cos of 5 theta, plus then that's going to be 10 over 32 is going to be 5 over 16 cos of 3 theta, and then 20 over 32 is going to be 5 over 8 cos of theta. Remember, it's a calculator exam, you can check all of those, and that's it. Okay, excellent. Rattle through that, but what we've done there today, we have shown how you can write powers of cos as either cos to the power of n theta, or else you've got writing cos to the power of n theta as powers of cos.